Hello guys, in this video we are going to discuss the solution of the problem combination sum 2. So let us look at the problem statement. The problem statement says that given an array of integers a or r, the length of the array n and an integer k, find all the unique combinations in a or r where the sum of the combination is equals to k. Each number can only be used once in a combination. Return the combination in the lexicographically sorted order, where each combination is in non-decreasing order. So let us try to understand the problem statement with the help of an example. So for instance, in this example, an array is given to us whose size is 5 and the contents of array is 1, 2, 3, 3 and 5, and the value of k which is given to us is 7. So within this, the various combinations which we have are two combinations, which is 1, 3, 3, which adds up to 7. The other combination is 2 and 5, which adds up to 7. Thereby, these are the two combinations which we are going to return. Similarly, in the next example, if you see, the sum which we are looking for is 30, the length of the array is 6, and the content of array is 5, 10, 15, 20, 25 and 30. Now here, the various combinations which could yield to a sum of 30 is 5, 10, 15, 5 and 25, 10, 20 and 30. So these are the three combinations which we are printing over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us take an example. So let us take the first example which we have, where the length of the array is 5. The sum which we are looking for is 7, and the array which is given to us is this. So in order to find out the right combination, we need to generate all possible combinations. While generating all the possible combinations, the only thing which we have to take care is, if the current sum is greater than k, then there is no point in proceeding forward, and from there we can simply return. So this is the only optimization which we will do in our code, is if the current sum or the combination which we have generated, in that combination the current sum exceeds k, then there is no point in exploring other combinations from the same set, because of which we will return from there. So now let us see how we can generate all possible combinations optimally. So the way we are going to do is, so this is the array which is given to us. So our combination can start from any of these elements. So our combination can start from either 1, or it can start from 2, or it can start from 3. And since we have to generate all the unique combinations, so this 3 and this 3 will amount to just this 3. And the other way we can generate all possible combination is the combination is starting from 1. Now let us explore all these branches. With 1, other combinations which are possible here is 1 and 2. The other combination which we have is 1 and 3. Similarly, 1 and 5. Please note, of these 2, 3, I am using just 1, 3. This is because we need to generate unique combinations. Similarly, for 2, the various combinations which we have are these 2, 3 and 2, 5. Similarly, for 3, the various combinations which we have is 3 and 5. And from 5, 5 is the lone element there, and there is no further combination with 5. So over here, of all the combinations, we can see that the sum of this combination is greater than k, and the value of k is 7, because of which we are going to rule out this combination, which simply means we are not going to explore it further. So from the rest of the combination, as we can see that this combination adds to 7. So let us say this is our answer list, and we are going to append 2 and 5 in this answer list. So now let us explore further combination. So with 1 and 2, the combinations or the possible combinations which we have is 1, 2 and 3, and the other combination which we have is 1, 2 and 5. Similarly, with 1 and 3, the combinations which we have are 1, 3 and 3, and the other combination which we have is 1, 3 and 5. Moving forward, the next combo which we have is 2 and 3, so let's explore that also. So with 2 and 3, the combinations which we have is 2, 3 and 3, and the other combination which we have is 2, 3 and 5. Now let us cross out the combinations which are greater than k. So this combination, as we can see, and this combination and this combination, also this combination, all these combinations are greater than k, because of which we are going to rule it out and we are not going to move forward for these cases. Now of these two combinations, as we can see, this also satisfy our condition, because of which this will be pushed into our answer list. So let us explore these two combinations further. So the first combination which we have is 1, 2 and 3, and the combinations or the various combinations with 1, 2 and 3 is, so let me write down the ARR also, 1, 2, 3, 3 and 5. So 1, 2, 3 we have already taken, so this will be 1, 2, 3 and 3, and the other combination could be 1, 2, 3 and 5. Similarly, with 1, 3 and 3, the other combinations which we have is 1, 3, 3 and 5. Now out of these combinations, this combination, this and this combinations can be ruled out because the sum is greater than k. Now in this way, as we can see, now there is no further combination left to explore, and the answer would be this combination and this combination, which we are going to push into our answer list, and that is what something which we are going to return. Now in order to satisfy the condition of non-decreasing order or lexicographically sorted order, what we are going to do is we are going to just simply go ahead and sort the array. So ARR array, this array will be sorted in increasing order, and once we sort that array in increasing order and we perform this logic, we will be able to generate all the combination in lexicographically order. So now let us discuss the pseudocode for this problem. So combo sum is something which we want to generate, and ARR is given to us, and for this function we will assume that the ARR is sorted. So essentially, before invoking this function, we will sort the array and then we will pass that ARR to this function. So ARR is given to us, and I is the current starting position of the combination. Then we have n, which is the length of the array, k, which is the sum, current sum, which is denoted by current sum, and path. This is the current combination. So the current combination is something which we are keeping it in path, and we are going to use this. So now the first thing which we are going to do is we are going to check if the current sum is equals to k. So if it is equals to k, then that simply means that the path, whatever value we have in path, that has to be pushed into answer. So let us say answer is a global variable, and we are going to append answer by this path. And since in Python it is all called by reference, so in order to make a copy, we are using path.copy. Otherwise, if current sum is greater than k, then in such case we don't have to proceed forward. We can just return from the function. Okay. Otherwise, now let us work on generating all possible combinations. So in order to generate all possible combinations, so for j in range, so over here let us say I is the position, or I is the starting position of combination generation. So for instance, what do I mean by this is, let us say the array is 1, 2, 3, 3 and 5. Right now we are at this position, so let us say I is at this position. So from 2 onwards we want to generate all the possible combinations. So our combination will start from I and it will go all the way till n. So that is what I am doing over here. For j in range of I and all the way till n, we are going to generate combination. So within this, since we want a unique combination, so we are going to ensure that if j is greater than I and ARR j is equals to ARR j minus 1. In such case, we don't have to do anything and we just have to continue. Okay, so let me explain this. So for instance, if 2 is over here, then 2, 3 is one combination. And let us say if we have already generated this 2 and 3 combination, so this 3 is this, then moving forward, then again this is 3. So again this 2 and 3, the other combination will be generated, and this is something which we want to avoid, and this is how we are avoiding it. If arrj is equals to arrj minus 1, so if this is equal, then we don't want to pursue that combination and we will just continue to the next combination. Otherwise, we want to generate combination and we want to operate on it. So now let us call our combo sum ARR. So jth element is something which we have already used. We want to generate from j plus 1. So j plus 1, and then n is given to us k, and the current sum will be equals to current sum plus ARR j. And what is the path so far, or what is the combination so far? Well, the combination so far is path plus the next element, which is ARR j. And please note, I have made it into array, and then that is what I am appending to path. Okay. So over here, please note, path is not getting updated. It is just that I am adding an element into path, and that element is something which I am passing. So the path will not be updated over here. And in this way, we will be able to generate all the combination sum. And then towards the end, this answer is what we are going to return. Okay. So that's about the pseudocode, folks. Now let us see how we have implemented this in Python. So the implementation is pretty much the same as what we have discussed. So the first thing which we want to do is sort the array. Then this is an answer list, and initially it is empty. And then there is a path list which is initially empty. Then we are invoking combo sum with array index 0, n and k, current sum 0, and path. And towards the end, we are returning answer. Now let us look at combo sum function. Well, combo sum function, if the current sum equals to k, then we are appending path into answer. If current sum is greater than k, then we don't have to proceed forward and we can return from the function. Otherwise, we are generating all the possible combination. So this is the optimization which we have discussed, and this is how we are generating all the combination. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.